Hello and welcome to Managing Your Kubernetes Fleet with Tanzu Mission Control. I am your host, Lawrence Kohan. Hope I'm pronouncing that correctly. Okay, one sec. Gin is our friend. Okay, so I've been in the field for 28 years or more, something. And my career kind of parallels the rise of virtualization. I really loved what VMware was doing with vSphere, and I kind of came up the ranks with that. And I've kind of noticed a lot of parallels between virtualization in the cloud era and where Tanzu fits into all of this with Kubernetes. For the past 10 years, I've been at Dell EMC and VMware, and now I'm a solutions architect at TerraSky. So what is Tanzu Mission Control? Well, as I said before, it's VMware's answer to managing Tanzu across all your different environments. So think again, virtualization, they would abstract the hardware layer so that you had the hardware of your choice, right? So in the cloud era, with vRealize or ARIA, again, you could provision and manage your workloads in all of your clouds, on-prem or any of the public clouds. Tanzu's approach, again, wherever you want to deploy Kubernetes, it allows you to manage at scale for enterprise class customers your Kubernetes clusters, whether they're on-prem, AWS, Azure, GCP, Oracle, all of the clouds, right? So as you can see here, you have attached clusters, and it includes policy management, cluster lifecycle management, data protection, your application catalog, and your IAM. So let's start with the first step would be to create and register your management cluster, which would either be Tanzu Kubernetes Grid or vSphere Tanzu. So for those of you who are running vSphere 7 or above, you have Kubernetes natively baked right into vSphere. So you create your vSphere Tanzu clusters. So you could use those as your management cluster. And then from there, you would create or attach your other workload clusters. Hopefully you can see this in the screenshot. So when you go to create a cluster, you'll see the ability to create an EKS cluster or create an AKS cluster or manage existing EKS or AKS clusters. And this gives you full lifecycle management. This is called registering a cluster, right? Or you can attach a cluster, which lets you ingest management of any other Kubernetes cluster that is CNCF conformant running in any other cloud. And the purpose of this is so that Tanzu Mission Control can give you that one plane to manage your entire Kubernetes fleet wherever it's running, apply your management, your policies, your guardrails, security measures, and so forth. So let's take a look at your multiple types of clusters. Right, so as we said before, you would start with the concept of creating, vSphere Tanzu refers to it as a supervisor cluster, or your TKG, which could be running on-prem or in a VMware cloud. Right, so you would first register that management cluster. And did this slide move? Or you can attach, so for example, here we see OpenShift and other clusters, right? Or you can register or add existing EKS clusters in AWS. So let's talk about resource hierarchy. So the concept here is you have your Kubernetes clusters, which could be disparate, running in all different locations, and you have your Kubernetes namespaces. Tanzu Mission Control introduces the concept of cluster groups and workspaces. And really what this allows you to do is create a cluster group, which you add all of the clusters to that should be in a uniform policy, or the concept of workspaces for namespaces, right? You group them together so that uniformly you can add your network security custom policies so that they all behave the same way and conform to guardrails, whether they're on-prem or in any one of your public clouds. Let's make this go. So here's an example of using cluster groups and workspaces and applying policies within the same Kubernetes framework so that you can create your policies for your platform operators at the cluster level or your application operators at the workspace level. And the purpose of this is for the global policy management. So you have separate logical groups for platform and application teams. You have consistent policy of applications across all of the attached clusters wherever they live, and minimal involvement of your help desk and security teams. So let's take a look at a few use cases for a customized security framework and how TMC would address these issues. So for example, unified security policy for a fleet of clusters in disparate public and private clouds, right? So using the concept of cluster groups and workspaces, you're enforcing consistent guardrails on your dev environment, your stage environment, your production environment for clusters, so that each one has its proper security protocols in place, network policies, and maybe you need custom rules for dev that are different from production, for example. But the concept of cluster groups and workspaces makes sure that wherever those reside, again, the same policies and guardrails are going to apply to those. So always enforce pod security settings with mutating policies. So this is API-driven policy definition and enforcement. And you want to maintain granular control on clusters and namespaces. So policy enforcement gives you a dry run mode to ease adoption. Pod networking restrictions. There are admission policies prevent non-compliant pods from initiating, ensuring regulatory requirements are met. So in essence, and we'll talk about this when we get to mutating policies, you can make sure that when you're creating new Kubernetes clusters, they're going to conform to the guidelines and the requirements that are created. However, you also do have the ability to adjust them for future use cases, and making sure that everything is templated and created in a uniform manner, right? So it's predictable, repeatable. Here's an example of using policies at the workspace level to restrict access to image registries. So for example, in the drawing, you can see your app ops people who, let's say they're required to pull different images from your GitHub repositories. And let's say I want to make sure that in either a dev or production environment, they have access to like Google container registries and pull those down, or Harbor registries, but I don't want them to pull down Docker Hub images. So at the image level, I can allow or restrict the ability to pull down those images for dev purposes, production purposes, and so forth. So when you restrict at the image registry level, you can require digest. You can tag using, for those of you familiar with the concept of tags, you can use tags as your policy for allow or deny. So you can block your latest tag, or you can actually create your custom rules. So in addition to your security network image policies, there are custom templates so that you can create your own in addition. Here's an example of restricting network access at the pod level. So network policies, predictable. You can either, kind of similar to the concept of NSX firewalling, where you have deny all, allow all, deny any for a pod, allow all for a pod, or custom ingress or egress rules. So in this example here, we have, again, for the app ops users coming into a workspace, and we have I don't know if you can see in the drawing, there's an example of Kubernetes objects that have a coffee shop label and a bookstore label. So the policy allows ingress traffic to the coffee shop tagged items, and it restricts ingress traffic to the bookstore items, right? And so you can use this not just for ingress in or out, but if you wanted to isolate certain Kubernetes environments from others at the workspace level. So again, it would apply to anything that's a member of that namespace. You can control CPU and memory quotas for your organization. Again, in the VM world, this is also big, like with VRA, how you have to create your policies to make sure that users aren't over provisioning. Very similarly, you can create your quotas as well. So to make sure that you have a handle on the resources that are being used for your Kubernetes environment. You can create your own security policies that meet your needs. As we were saying before, you can use these for compliance purposes. Security policies can either be very, very strict, as we were saying before, deny all, or they can be a little bit more relaxed. Again, so maybe it depends on the dev environment. the dev environment or the prod environment. So let's say for dev purposes, you want to leave it open-ended, but for more production environments, maybe you want to have things more locked down. So you can create, it's very granular how you create your policies. So that's a cool feature. Enforcing policy as code. Here's what we were saying before, where you can actually create your own policy template in addition to the boundaries of security, network, and so forth, based on OPA constraints, supports namespace selectors. It comes with pre-built templates, and this future-proofs you against the deprecation of pod security policies that I believe were deprecated as of November last year. And here's a view of your detailed policy analysis in your organization. So it'll give you a list of all of your policies. It'll show you the current status. It'll show you aggregated detailed views, the ability to debug your policies. And it's really one place so that you can look for all of your violations and remediate, so forth. As you see along the top, it gives you the status, right, health status as to the state of your environment. Modify Kubernetes resources at request time. So this is the concept of mutating policies, right? So you have your mutation scope. You define the resources that are to be mutated, the intent, so the field and the value to be mutated, and the conditions to apply the mutation. So this ensures consistent deployments and environments regardless of your infrastructure, consistent security guardrails enforced regardless of your infrastructure, and creates policies once and applies to many. So this eliminates the possibility of human error, and it ensures Kubernetes metadata rules and security guardrails are enforced on all objects. And here's an example of setting up a mutation policy. So you configure your defaults and your enforcement conditions, and this shifts the security burden away from the developers. So it's something they don't have to think about. They should just be writing code, right? So this is more of an infrastructure function. For those of you who want to take the VCP AM exam, this will be on the exam, so take note of this. They'll ask you a question in some way. There are 3 different inspections you can run against in TMC. Right, so there's your conformance test, which ensures that a cluster conforms to official Kubernetes specifications. This is a long test. This could take hours to complete. On the next slide, you'll see an example of where it fails, warnings, and the tests that pass. And you can expand a drop down to see what needs to be remediated to be in compliance. Then there's a CIS benchmark, which checks whether Kubernetes is deployed according to security best practices as defined in the CIS Kubernetes benchmark. Then the last test is a light test, which is really just a very quick analysis. Overall, is the cluster in a healthy state or not? Now, you can run these inspections directly against Kubernetes clusters, or you can create a cluster group, run it against the entire group, and it does it all at once. Right, so for example, that's very useful for the conformance test, which could take hours for a cluster. Right, so maybe on a Friday afternoon, you create a cluster group, all the clusters that you need to run a check against, run it, it'll run against all of those clusters, and hopefully it's done by Monday morning. So here's 2 examples. Here's a quick look at the CIS benchmark inspection, and you can see there's a couple of failures, a couple of warnings. Now you can open these up, drill down, find out more information about what failed, what's warned. And we do have a couple of good ones, and this is actually a much longer screen, so there's actually a lot of green. But again, so it gives you information on what's conformant, what's not conformant, what you need to remediate. And then in front is a quick light inspection. So this is a very quick test against the cluster, just to make sure it's in a working state. And ideally, you want to see all green in that case. Okay, complete data protection by powered by Valero. So you can use TMC to manage backups of your environment as well, data protection. Right, so you can back up your clusters, your namespaces, using your labels to define. You can schedule your backups. You can back up to any S3 compatible or Azure blob target. You can configure backup targets for cluster groups and clusters. You can cross-cluster restore. We'll see an image of that. And there's support for PV backups, custom CA support for storage targets as well. So using multi-cloud Kubernetes with cross-cluster restoration, you can recover your applications quickly, replicate production environments for staging or testing, backup target flexibility and choice, or you can move applications between any CNCF conformant cluster, right? So this is what we were saying before about attaching disparate clusters in different areas. We were talking about attach before, right? So registry, you're managing the entire life cycle of the cluster that you're creating. In the case of attaching existing CNCF clusters elsewhere, you don't manage the entire life cycle. However, you can still do all of the other functions. So aside from create, destroy, and upgrade, all of these things about applying policies, grouping them into cluster groups, applying our integration, leveraging other components of Kubernetes, you can still do that with all of your other CNCF conformant clusters. So you can use them as backup targets. You can back those up and again, restore them to other clouds. So this is good for a lot of DR use cases. Let's see, so you can create a full cluster or namespace scope for backup actions. And as we said before, you can choose any S3 compatible storage target. So build and integrate anything. So leveraging API, all right, this is kind of like an anything, build anything as a service. So this browse API calls that can be programmably controlled resources. You can extend or integrate TMC functionality with other systems or workflows. So a few examples, you can automatically check for cluster placement, move to proper cluster groups based on certain values such as locale. You can automatically provision clusters for developers based on specific help desk ticket types or values with predefined guardrails already in place. You can automatically assign access policies for clusters or regional support staff based on geographic locale. And you can also use Terraform with TMC as well. Supported operations are cluster and node pools, cluster groups, namespaces and workspaces, your policies, IAM, image, security, and your custom. Tanzu service mesh integration as well, and for credential management. Supported cluster operations, you can provision with Tanzu Kubernetes clusters on vSphere, or with Tanzu services, vSphere and AWS. You can provision AKS clusters, and you can create and update cluster node pools and settings, and cluster attach. Continuous delivery with Tanzu mission control. Let's do a time check. Okay. You can define resources once as YAML and then reuse them across your entire cluster fleet. This improves DevOps cluster handoffs. You can store credentials that only propagate when required by a repository, and you can manage Helm deployments on clusters with public and private repositories. And we'll be looking at that soon. Right, so you can see directly from the TMC console, you could pull down your packages, your Kubernetes-related packages such as Valero or FluentBit, and pull them down and install them right to your Kubernetes clusters, or your Helm charts. So you can install any Tanzu standard packages. You can install Bitnami, public Helm packages. Public and private Carvel repositories are supported. Private Git Helm repositories supported by continuous delivery features. And this is powered by the KApp controller. This is all command line too, but right from the console. You can pull down, you browse your packages, pull them, install them right to your cluster. View and analyze events. So Tanzu Mission Control continuously collects and stores logs of audit events that describe activities that occur in your organization. You can generate a report of audit events for your organization, and you can also see when these operations were applied to the cluster. So auditing, log management, that sort of thing. So if you want to take a screenshot of this QR code, this will take you to the TMC Tech Zone page, where there's a lot more information, blog posts, any updates related to TMC, new features, things you need to know about, current status. That QR code will take you right to the main page, so you can get any more info you need. And with that, I want to thank you. And if you require any more information with Tanzu, TerraSky specializes in Tanzu implementations, customization, integrations with your environment, and you can contact us to help you out with anything else you need. Any questions?